Talk about a break. Oh, man. Well, thank you for the introduction, and give it up for Amsterdam. What's going on, everybody? What a turnout. Wow. Don't be confused by what looks like some sort of like confidence. I am shaking by how many awesome people I see right now. But yeah, let's get into the talk. So, as I mentioned, my name is actually Narcisse. I'm a staff engineer at Apollo GraphQL. And first thing, I'll be missing out on a perfect opportunity to just absolutely represent the flag. So, yes, coming from the motherland of Haiti. Oh, no, upside down. No, y'all didn't see that. But yeah, today we're going to be some Haitians. I'm going to turn all y'all into Haitians today. Man, loving the energy. Yes, let's do it. So, as I said, I'm going to turn y'all into some Haitians. And first thing is going to learn a Haitian greeting. So, it starts by, the call is like sac passe. And then the response, and I want y'all to engage with me, is map, boo, and lay. Right? So let's try it. Sac passe. One more time. Sac passe. All right, let's get it louder. Sac passe. All right, awesome, great. You guys are now Haitians for the next 24 hours. That's how much I was able to squeeze out, but definitely get maximized on it. So, I'm going to talk about Auth Thingz, and Auth is a pretty loaded word right now, but I'm going to be focusing on authorization. There's tons of resources out there talking about authentication, and tons of great companies and developers creating content on it. But authorization hasn't been getting too much love. And coming from Apollo, obviously I want to talk about authorization as it relates to GraphQL. And specifically, the type of authorization is going to be enforcement within the SDL. If you're not too familiar with GraphQL, it's kind of like description language. If you're familiar with Auth or Swagger, you have a specification for your API. But it allows you to kind of like decorate your schema with these little kind of like annotations. Here's, we're going to squint really hard and imagine that this auth thing actually worked. And then it powers certain like logical checks that we're going to be performing on our fields on whether or not that data is going to be returned or not, or so. So to understand a little bit why this is kind of like, I wanted to like really dive in onto this, and I kind of want to say, well, what's that risk? If we look up CVEs, which are these like disclosures on like common foundings on like vulnerabilities, there's this national database. If you look up, just simply search for GraphQL and Control F, you'll find that there's a couple findings out here. There's an awesome company that focuses on GraphQL security called Inigo, and they kind of like did analysis on the different vulnerabilities and exploits that have been reported as it pertains to GraphQL. And they found that 54% of findings within the CVEs are related to authorization bypass. So this one essentially, specifically as in OAuth, it's like broken object level authorization. So it's not necessarily that they took advantage of certain sort of bug, but it's mainly some sort of gap in how the logic was implemented. And essentially, there's people are taking advantage of that. So there's also another source for vulnerability findings called HackerOne. They have this awesome bug bounty program. Think of it like GitHub, but for hackers. And they found that 87.3% is also related to authorization issues. They do talk a little bit about like, what skews this more, because not a lot of companies are open to just letting hackers just free range, just do some penetration testing. So that kind of like skews the scope. However, that still, underscores the fact that this is still an issue. So me working and being responsible for, securing some graphs, my reaction is like, hey, yo, we gotta do something a little bit out here. So that is kind of fine, because you start to understand a little bit of like what it feels like to be Haitian. Ma boule literally means I'm burning. There's a lot of cultural context and the stuff that we see currently happening right now in Haiti, of the stuff that you see from insecurity, the political instability, but the Haitian people are resilient, so that has become part of just everyday colloquialism, where how are you doing is just I'm burning. It literally represents I'm fine. We're gonna push through it. But don't worry, there's hope on the horizon. And hopefully this talk is going to be a way that we can maybe reset the conversation around authorization and see, kind of open up some new avenues for exploration as it pertains to authorization. So I love mental models, and this talk is going to be very heavy on mental models. So I apologize if we thought we were going to do some dope demos. I think I would love to, in the future, channel my inner Kelsey Hightower, but for now, we're going to start with the model, and we'll see you in the next talk. Authorization and roles go very, very well hand in hand. Well, together. Like, it's a great way of communicating that to our end users. If you don't have this role, you can't perform this action. So RBAC is a really great first step, especially when you don't really know how far your system's going to go. So you take the best, lowest risk option when you're implementing your features. And this has a really good, strict order to it and can be enforced. So it makes sense when you're building and enforcing that within your system and communicating that to your end users. You might do so as an enum. Enums are great. Types are great. Even if behind under the scenes it's still strings, there's still an intuitive order that's associated to these roles. Now we're going to go into a little bit of pseudocode. So that annotation that I mentioned before is a directive. And you can essentially define the code that this directive performs using this directive wiring. So this is our pseudocode. So if in the directive I had mentioned that the field was, hey, you need to be a reader in order to get access to this data, we could simply do a check and say, well, if the role for this user from our authentication pack, whether that's coming from OAuth or AuthZ, whatever authorization mechanism, that role is hydrated into our context. And we can go ahead and do a check. And if not, we just yeet them out, and it's up to their problems to, you don't have to roll for this. But there'll come a time, as you're evolving the system, where there's a particular role that you need to do that just doesn't make sense, and it kind of breaks it. And then, you know what, it's no problem. Maybe I could do an if-else case here that breaks out of this particular linear check, but you'll probably be 3 iterations down the line, and your authorization code turns into this really nice spaghetti mess that you try to avoid. A great way to refactor this is to start thinking of your system and abstracting out your capabilities. Reading a user, writing a post, et cetera, you define those, and you can group those under a particular role. And that way you don't break the user's expectations or the UI, where it essentially says, you're still able to do a specific set of things, but under the hood, the abstractions are easier for the developers to continue to build upon. And this is perfectly fine, right? When you need to expand on that, you can create a special role. Maybe there might be some sort of special auditor. I don't know if you're doing a SOC 2 compliance, and then they need to be able to read everything throughout the system except for maybe the most sensitive information. That is one way you can kind of enforce that, right? While doing it within the mechanisms of the system. So this gets closer to attribute-based access control, even though it's exposed to an end user as a role-based access control. But very much attributes is what's powering everything. So out in the wild, we all use Slack. Hopefully all use Slack or Discord. But they have this really awesome UI that really breaks down and shares, hey, here's the capabilities that are available for these users and what they do not have availability for. So this gives them the hierarchy, which as your system grows and scales, right, you might get to a point where, well, we need to break into the monolith, or you're leveraging some sort of microservices, or in the case of GraphQL, different subgraphs. And each domain owner can define their permissions as it pertains to themselves without having to worry about, oh, these enums also need to get duplicated all throughout the code base, because we're in a shared code base, and it's because of that, everyone gets access to the poop domain, that even though they're not using the poop domain. So how does that kind of translate a little bit into our directive state, right? If we're using OAuth, or we have some JOT token, we might hydrate our JOT token with the scopes available for that person's role. We resolve their role based on some sort of database lookup, team, organization, etc. That's all hydrated in there. And with that available, similarly to our previous directive function, we can evolve that to being able to support different claims and scopes. We can even go a step further, where maybe it could take an array of scopes that we do a checks on. So we're still good. And this is definitely stuff that's being done now. And the reason why I want to kind of like approach to this model is as you have different services, right, you want to kind of keep your auth check consistent across the different subgraphs. So you might want to extract your authorization kind of like server into a centralized location so that as you're increasing, you can minimize kind of like the complexity of needing to change or evolve your permission landscape. So that's great, but there's a few other things that help us centralize our permissions. And that's where we get into like policy-based access control. There are a few systems out there that are available. There's OSO, Cerbos, Caspin, and Open Policy. And these are allow you to kind of like provide and project like kind of your permission system within internally. They give you these sort of like DSL where you can attach or define these rules like we were doing before. Can a user, well, is a user even an employee? Are they an owner of the resource? Are they a particular like level of player or entity? And you can define these rules within their DSL and publish them all somewhere. Now this is great because now your PMs, your engineers, even your testers are now speaking the same language. And even better, you can use these DSLs to even write tests and assertions against the policy engines, where it becomes easier to write this difference and contain your authorization assertions in a separate way, as opposed to kind of like mixing it all in within your different test domains. And that might also be fine. However, depending on how your authorization is implemented, that adds additional complexity to the type of test that might potentially discourage engineers from even writing those sorts of tests, which introduces a new gap, which leads to, oh, the system was running fine as expected. However, here's a particular edge case that wasn't being tested and was exposed externally. So I mentioned Rego, Polar is the DSL by OSO. They have these slight variations. However, they're still boiled down to being able to express different sorts of entities, the permissions attached to those, as well as the roles and enforcements that you want to make. And Kerbals takes the YAML approach. If you don't want to learn a new language, use what you know. That's also great. So options, great. Let's see how that ties into GraphQL. That's we're going to circle it back in. So let's call these policies. Another one that's kind of close that I didn't list here was like GraphQL Shield. When it comes to GraphQL, GraphQL Shield is a really, really great package. However, you're not able to centralize these policies elsewhere. GraphQL Shield is embedded within each and every one of your subgraphs. So that's why I didn't kind of mention it here. However, back to our policies, when we get to a particular field, right, we understand who our user is, and we have at least the ID or the full payload of the entity that we want to operate against. So we can perform our rule check. So I say, hey, go ahead and look up our custom rules. Here's some payload about who's acting as well as what I'm acting upon, and let me know whether or not I can proceed. And that is a huge step forward for authorization, especially as it pertains to your doing that across multiple subgraphs in the GraphQL landscape. And this might very well look the same for your existing systems, right? For REST, it's or at least REST services, authorization, there's a lot of stuff that makes sense, but like there's a lot of things that kind of like change. The call paths aren't as easily predictable in GraphQL as it would be through a REST path. So in consistently enforcing permissions as the domain context changes across the request path, the query path, that's really where kind of like the complexity and the challenge lies for GraphQL. So one thing I want to bring up is that context is supreme. So Wakanda forever, I just had to drop that. But really context is kind of like at the core of what allows us to project or like to secure permissions, right? Yes, a user might have a role of reader, but are they in the right org? Have this document been shared with them? that is additional logic that we have to still write and check in addition to our authorization check. So things like roles there's a little gap there. With attributes, a very similar situation. Yes, I have a reader attribute, but that doesn't provide me read access across all organizations. So I still have to write that code. So there's still that context that's being projected. Policies, very similarly. However, policies allows me to encapsulate all that context checks all within rules. So now I'm effectively communicating and packaging these permissions out. So let's take a quick little step back. So I have a channel. We have owners, editors, viewers, and an owner can do anything an editor can do, and an editor can do everything a viewer can do. This is a pretty simple way of thinking about this. A channel is within an org. Orgs definitely have members, and members should be able to at least view everything that's in the channel. Now, this is not a complete view. However, hopefully, you maybe might get an idea of where I'm getting to in terms of we're encapsulating a lot of context here just by leveraging a graph. And all the relationships are being associated. Now, whether it is the right identifiers, that is the next step. So that's where we get into graph-based access control. Ding, ding, ding. When, over the past 5 years, 10 years, or even 15 years, a lot of references to graph-based access control has kind of pointed to or assumed that you have a graph database. And graph databases are really great for writing these sorts of assertions. But really, you don't necessarily need to have a graph database to leverage this sort of permission model. So that's where there's been solutions that have been introduced and where it's been kind of renamed to relationship-based access control to be a little bit more friendlier to the context. So let's play a little bit of GeoGuessr. Sorry, if this seems pretty mundane right now. I love Auth. Hopefully, I'm gonna make this very interesting for y'all. Can anyone guess where this location is? Haiti. I love that answer. I wish it was. We do have a place to look very similar, but Haiti is not it. Any other takers? Feel free to shout. Fiji. I love that. And what is it? Bahamas. Any continent maybe? Continent guesses? Africa. Yes, I heard Africa. And yes. Thanks everyone for playing. Come at me later. I got a little sticker for you as rewards. That's for everyone, not for whoever guessed it right. But before we get into where this was, let's kind of recap a little bit on our roles. So role-based, RBAC, we're doing role checks. ABAC, where it's all about the attributes, right? Let's look at fields around our entities and confirm if or not we're able to do so. Ooh. Sorry about that. PBAC, it's rules. Think of it like your recipes, right? Let me go on my recipe site and confirm the ingredients and whether I'll be able to successfully bake my authorization. Thank you. And then reback, relationships. Relationships is things, and the relationships allowed us to convey and project the context. Thank you. So this location is Zanzibar. Ding, ding, ding. So if you've been kind of keeping it's also known as the African Maldives. So if you're looking for a honeymoon location, also consider Africa. But Zanzibar, this is a kind of call out to Google's Zanzibar implementation. They released a paper 5 years ago. I'm losing on the math right now. But it's what powers, is their central distributed authorization system that powers all their products. Google, Gmail, obviously Google search, YouTube, Google Cloud, they're all running on the same authorization system. What I wanted to really kind of emphasize here is that these different applications have different authorization needs, authorization structures, and topologies. So how is one system able to truly carry that forward, as well as being context aware, because there's ways that you're projecting workspaces and organizations. So clearly there's a power and flexibility here that is intrinsic within graphs that we can kind of link into our graphs. So I won't go too much into how it works because I'm running low on time. However, that's to also say that Zanzibar is kind of web scale. Actually, it is web scale. But there's a lot of other implementations that can take you pretty close to that layer. You can learn more at Zanzibar.academy. The awesome folks at AuthZ have created tons of great educational context, synthesizing the key pieces from that research paper that Google released, as well as how they've applied and interpreted those findings into their open source solutions. So going back to why is it relevant? Federated data graph and how we're capturing and conveying all our entire domain for how our data is. That's what GraphQL is really great at. But when it comes to authorization, maybe Zanzibar is probably the right pairing, especially if we consider the structures where roles are linear and attribute-based access control can probably be just like a massive sprawling tree that doesn't quite work well too much across different domains. Authorization graphs gives us more flexibility to work within a context where we have a data graph. So similarly to how we had our policy-based access control, we can still define these relationships, or like the boundaries of these relationships, using the DSL that these system provides. So this one is from OpenFGA, which is the open source offering of AuthZ's FGA, which used to be called Sandcastle, Project Sandcastle. But still, you're defining it, you're storing and centralizing these permissions, and you're building up that context. Now, how are these edges performed, right? How does the permission checks perform? Because it's decoupled from your system, it doesn't need to be aware of anything about your particular data. All labels are just identifiers. So I can say, hey, a user identifier, and that's kind of how I can prefix it, that I know that this is a user entity, and it has a UID. This could be a UID, a string, a number, whatever that identifier is within your system, and you can ask it, does this entity have a member relationship with another entity, regardless? And due to the boundaries that we defined in our previous schema definition for our relationships, OpenFGA or whatever Zanzibar implementation will go ahead and check to see if there is a path available. And underneath, it creates a directive acyclic graphs or DAGs. And that's kind of how they're also able to project groups due to those transitive closures. So going back to our directive, great. We can go ahead and spin up our Zanzibar-like implementation, go ahead and hydrate it with all the rules and permissions, go ahead and do a migration of our existing data system, authorization system, and copy that data over. And then simply modify our directive to do a simple auth check that checks the relationship across entities. That's all. So what's available? How can we go ahead and try this out in the real world and play it? Maybe in a dev and staging environment, preferably. But as far as cloud-hosted solutions, there's AuthZ, FGA, like I mentioned before. There's AuthZ, which was one of the earlier players in the scene as far as implementing Zanzibar. And there's also Cloud, who takes a different approach where they combine a lot of these similar things with policies, but they have these things called facts that also allow you to project relationships. Open source solutions, because you might be a bootstrapper like I am. I'm spinning up projects left and right, and I ain't got cash for that. So OpenFGA, SpiceDB, and Orikeeto are some good players that you can use to test out and actually embed it within your system. So to quickly recap and rebase, authorization is difficult. We need to be very mindful around the models that we're applying as it pertains to our data layer. Since GraphQL is a graph, let's also apply a graph authorization model to work well along with it. There's a lot of open source solutions that we can go from. I will be posting links on my website and Twitter. I have not posted it yet, but if you do want to keep track on it, feel free to note my Twitter and website, or just ask me in the crowd. Thank you so much. My name's Ashley. And sac passe? Great, thank you so much.